Well, hey there, it's John here, and I'm back in the Eastman Discovery Lab at the Hands-On Discovery Center with another activity that you guys can try at home. I'm sure by now you all know my favorite chemical is dihydrogen monoxide, or water, and that is going to be the star of this experiment today. Water has a very cool property called surface tension, where molecules, water molecules, especially at the surface, tend to cling together and create like a skin that holds in the water underneath it. You've probably seen, or may have actually done, an experiment where you take a penny and you actually add droplets of water to the top. You can get like 40 water droplets balanced in kind of like this balloon shape on top of the surface of the penny before surface tension breaks and all the water floods out in a giant tidal wave. Well, we're not going to be breaking surface tension using like the pressure of the water. We're going to be doing it chemically, using another substance that you probably have at home. Dish soap. Now, we are going to use this dish soap because it actually breaks the surface of the water by using, well, actually, if you look at a sucker here, it actually looks a lot like a detergent molecule. It has a head on one end that is very attracted to water, or called hydrophilic, meaning water-liking. The tail of the detergent molecule is hydrophobic, meaning it has a fear of water and tries to get as far away as possible. So when we have this detergent floating in water, it's actually going to poke that tail up at the surface of the water, thus breaking apart the water molecules holding together, breaking the surface tension. Now, to do this, let's get out of this. We are actually going to make something that floats on water. Now, what floats on water? Ducks, wood, a boat. Let's make a boat. Now, you want to think of things that will actually float on water already. Like here I have some styrofoam material. It's very lightweight, full of air. Plastic, thin sheets of plastic will actually hold on top of water because, well, that surface tension is very strong. You could also try cardboard or paper, but bear in mind, even though they'll float on the water surface for a while, they're probably going to get waterlogged and sink to the depths. So we're not going to do cardboard. Now let's go back to maybe the styrofoam. We're going to cut out the shape of our boat. Well, we need like a stern, the backside. That's going to be this bottom here. And I'm just going to cut out a rough shape, maybe a nice pointy bow, or maybe kind of a curved bow. That's fine too. And we need a motor at the back. For that, we're going to take our scissors and cut a little ways in, just kind of like this little slit at the back. Boop. And that's going to kind of act as like the motor where all of the power is going to come from. Hopefully, this floats on water. Here I have a dish of H2O, dihydrogen monoxide water. And it's not very deep. It's about an inch or maybe even 3/4 of an inch deep. We're just going to float our boat here in the back. Hey, she is ship-shape, but she's not moving. So to make her move, we're going to break that water tension, right? That surface tension. Let's try my little pinky, see if that'll break it. Get apart, water molecules. You may have noticed it actually moved the boat a tiny bit. But again, we're not going to be doing it forcefully. We're going to be moving it chemically. Here, my dish soap, I'm going to pour a little bit in this little cup. A little bit'll do ya. And using a Q-tip, I'm going to take just a tiny drop. Get back here, boat. She's already set sail. And I'm going to add just a tiny drop of this dish detergent right behind the motor. Ready? 3, 2, 1. Whoa! Just like that, the boat shoots across this pan of water because we've broken the surface tension behind it. All those little hydrophobic tails are pointing up in the air, breaking apart the water molecules, but the surface tension in front of the boat is a lot stronger still. All those water molecules are pulling each other together, and in doing so, they're actually going to pull the boat forward along with them. Now, if I was trying to repeat this experiment with the same batch of water, well, we could try it. Let's see if it works. Oh, not nearly as much, maybe a little bit. But with all that soap dispersing, spreading out over the water, we should probably take this water, dump it out, and refill it. Maybe rinse out the container to get rid of any soap residue. Luckily for you guys, I already have another tray of water right here. In this much larger tray, we also have my same favorite chemical, dihydrogen monoxide, and another boat that I've cleaned off. This is a clean of detergent and all of the hydrophobic molecules. This one, I've actually changed the shape just a little bit. Here you notice I've taken a hole punch and just snipped out a little hole in the middle. What we're going to do is we're going to take the soap and apply it right around the ring of that opening. That's kind of like adding gas power to your motor before setting sail. Now we have soap on the boat already, and all we have to do is add it to the tray of water and off she goes. And you saw it. I did not push the boat at all. I didn't like flip it across the water at all. It went on its own, all to do with water surface tension. Guys, try this out at home, and as I mentioned before, you can change up all these variables, like the materials you use to make the boat. You can change the temperature of the water. Does it work better with hot water versus cold water? You could also use different detergents. Here I use dish soap, but you could use, I don't know, bar soap or shampoo. See what combination works best, and then maybe challenge a friend for like a boat contest. Like this video, guys, if you enjoyed this activity, and subscribe to our channel so you never miss a new upload. Also, check out the description below where we're going to have information about water surface tension. Also down there, there'll be information on how you guys at home can help us keep the science alive. But right now, I just realized that my shoe's untied, so I got to take care of that. Bye, guys! It still has soap in it. Start from the top.